Coal. We've been using it as a source of energy since the days of cavemen. Today, the world uses 5.3 billion tons of it each year, and more than 3/4 of this goes for generating electricity.
Coal is a non-renewable fossil fuel that took millions of years to form from animal and plant materials under great pressure and at high temperatures. In addition to its reputation for having negative environmental effects, we have a limited supply.
What if we could replace some of the coal we burn with other sources, renewable sources, like trees, grasses, or agricultural residues?
Research at the University of Missouri has been looking into just that. And this research works hand in hand with Mizzou's sustainability goal of being carbon neutral by 2050.
On December 7, 2012, Mizzou Weekly reported that the university's new biomass boiler was expected to be running by early February.
It will reduce MU's coal consumption by 25% by burning 100,000 tons of biomass materials each year. Dr. Shiro Jose, director of the MU Center for Agroforestry, and others have been looking at various aspects of biofuel production as part of the Mississippi-Missouri River Advanced Biomass Biofuel Consortium. Research is important to making sure that this process is environmentally, economically, and socially sustainable.
It looks like a great idea when you talk about, harvesting biomass and either burning the biomass rather than burning coal, or converting that biomass into some sort of a liquid transportation fuel. It all sounds great. But again, think about the biomass and the sustainable aspect of growing that biomass. You can very quickly deplete the biomass resources if you don't pay any attention to the sustainability aspect.
At first, MU's biomass boiler will be fed using woody biomass coming from wood waste and managed forests. Managed is the key to benefiting both the environment and the economy.
So if you have a lot of overcrowded, small trees growing in a forest, there is a practice what we call thinning. You can thin some of those trees, and some of those low-value trees can be used for biofuels or burning in a power plant. And that way, you are supplying the wood for the biofuels or biopower industry. At the same time, you are improving the health of that particular forest ecosystem.
According to MU grad student Ashley Schroeder,
scientists looked at other states' BMPs in order to come up with
a 1/3 rule, which leaves one tree for every 3 harvested. Schroeder has been researching the effects of different timber harvesting techniques on nutrient levels in the soil to help determine harvesting standards Missouri should adopt.
From the data that I've collected so far and what Ryan has also collected, we're looking at that a traditional clear-cut harvest is probably still the best way to go. And then a couple of the intermediates that follow after that, and then the 1/3 BMP rule is followed after that. Looking at the nutrient levels, it's really not changing that much from an intermediate to the BMPs. So you can definitely see a change from the clear cuts to the control. Mm-hmm. And we can see short-term effects right now, but a lot of the literature has said in the long run, usually about after 10 years or so, things, nutrient levels go back to what they were before the forest was harvested. Mm-hmm. But then that means you'd have to space out your logging. Mm-hmm. If you were to go in and harvest again, like a short-term rotation, mm-hmm. then that would definitely affect the soil quality.
The next step in biomass is using perennials like switchgrass and miscanthus. The Mississippi-Missouri River Advanced Biomass Biofuel Consortium is looking at the production of these crops on marginally productive land along the Mississippi and Missouri rivers. Dr. Peter Motivalli, professor of soil science, explains some concerns and benefits of this.
If it's going to replace corn acreage or other major crops, then there's going to be an impact of that. and as compared to maybe putting it in marginal areas. And I think there's more vulnerability when we put it in marginal areas to have some kind of impact on the soil resource and also on water resources. So that's the real challenge here, is how we manage this. But in most cases, these grasses, such as the switchgrass, are very good at soil conservation. So planting something like switchgrass actually would help in reducing erosion. So there may be some multiple benefits from putting in these biofuel crops. There may be some benefit in terms of the physical properties of the soil of having this cover, replacing maybe an annual that was grown there and putting in a perennial. That may have some benefits.
A third option for biomass feedstock is agricultural residues, or the leftovers from harvested crops such as corn.
Most of the modern farming techniques now are maintaining residues on the soil surface after harvest, which is very important for soil conservation. And if that's removed and then used for biofuel production, that could cause greater potential for soil conservation, soil erosion. So we have to be very careful in the amounts that are removed. And there has been some research that has been done to look at what would be the break point, what percentage of the residues could be removed before you have substantial impacts, not only on soil conservation, but on the soil organic matter content. And these have, of course, impacts on soil structure and then subsequent soil fertility.
With all these concerns, why is it so important to be looking for alternative energy sources?
Critics of biomass are quick to point out that biomass does not actually burn cleaner, but there is an important difference.
Well, the difference is, one is carbon that was sequestered millions of years ago under the earth, and the other one is carbon that was sequestered, perhaps during the last few years. And if you are talking about like an annual crop, or let's say even a perennial crop like switchgrass, you are harvesting the carbon that was fixed during the previous growing season, not the carbon that was fixed millions of years ago. When you add carbon that was fixed millions of years ago back into the atmosphere, that can be a net increase in carbon. Well, on the other hand, when switchgrass fixes carbon dioxide, the biomass that you are burning, that much carbon was fixed from the atmosphere, from the existing pool into the plant. Now we are burning it and releasing the same amount back into the environment. The next growing season we will fix that carbon again. Well, the following year we will release that again. So it goes back and forth.
Burning biomass can generate many benefits, including renewable energy and alternative incomes, but we must maintain responsible management practices to ensure our renewable resources keep renewing.
Research is key, and the MU biomass boiler is a progressive step in understanding how we can make this a reality.